So she is a planetary scientist who specializes in the morphology of various planets in the solar system, and looking at the process of how these surfaces change. And she's into doing her work. She's worked on the Cassini team that's looked at radar from distant planets, including Saturn.
Yes.
And she's also in looking for models of this, she's traveled to the Egyptian Sahara and the Ethiopian Afar Rift Valley. So it sounds like she's had a lot more fun than I did in my career. So go ahead. Thank you.
First of all, a big thanks to the AV people. My presentation is all about pictures and can show pictures of the solar system, and so I'm glad that you'll all be able to see these a lot better. My approach to understanding, to speaking to you today is going to be to discuss how I approach what I love about the science that I study and what I love about the religion that I belong to. So my connections are maybe more tenuous than others, but you'll see a lot of pretty pictures at least, and I hope that will help you understand how I feel about the creative side of our Creator. Can I do this? Is that right? Yeah, there we go. Okay. We've begun our exploration of the solar system by starting with the inner solar system, the objects that are closest to us. And that's understandable because they're the easiest to explore, the easiest to study. So we've been there for a number of decades and for half a century or more. And these bodies are really fascinating by their own right, but they're also, they're sort of black and white worlds. You know, when we look at the moon, we see this grayscape. We see a cratered landscape. It's very old. Not much has happened to it since it formed 4.5 billion years ago. And the same is true for the planet, do I aim it at you? Yeah. The planet Mercury, which looks a lot like the moon. So we see evidence of impact craters. We see lava flows. Even when we go to Mars, for example, we see impact craters. We see evidence of rainfall on the surface. So there's some places on Mars that actually look a little bit like home. You know, we walk out and we could see these in southern Utah, dry riverbeds in a rusty landscape. But can you remember the first time you saw a picture of Jupiter? This is a picture from Pioneer 11. This was actually in 1974. And the spacecraft sort of had a camera thrown on it at the last minute because the scientists were not interested in pictures. They needed to take data from magnetic fields and things like that. But we did put some cameras on, and all of a sudden, this was just like a burst of color to us when we started to look out in the outer solar system. We could see these beautiful clouds around Jupiter, the bands and the zones that indicate the atmosphere is moving around. Here you can see Jupiter, and up in the upper left corner is Io, tiny little Io that I'll talk about in more detail. And finally, we're starting to look at worlds that are just beautiful and utterly alien to us. There's nothing like this that we can think of on the Earth. When we look out here, I guess we can think of this as, well, this is like a massive storm. And we might see something like this. This storm that we're looking at here is the size of Earth, the entire planet Earth. This is an image taken by the New Horizons spacecraft on its way past Jupiter to get a slingshot to head out to Pluto. And we'll get there in a couple of years. Sorry. Okay, thanks. And so here we can see in this beautiful picture just a whole lot of clouds, a riot of clouds and storms and an array of patterns that exist because this atmosphere is so vigorous in its convection. And it turns out that Jupiter is so big that if we descend far enough down through its atmosphere, we'll reach a point at which the hydrogen in the atmosphere becomes a metal. There's so much pressure. So the electrons are shed off of the protons and they just move around at will. And that's before we even get to the core, which contains rock and ice and metal. And so the other thing that's really interesting about these bodies is that not only are they beautiful in their own right with their atmospheres and their completely unique landscape, and I should mention, nobody ever thinks about living on Jupiter, but my niece, 12-year-old niece, just wrote a short story about a girl who lives on Jupiter. How creative. So you have to be a child to be creative enough to think outside of our own experience and realize, well, you could live on Jupiter. Why not? So she has that story. But instead, we look to the moons of Jupiter and Saturn and the other gas giants in the solar system for something that's something that we can grab onto that's a little bit familiar. And yet these bodies are still very unique. So here are the 4 Galilean satellites of Jupiter. They're named for Galileo, who discovered them in 1610. And you can see these actually to the correct size. So remember, the Earth, the red spot you see here is the same size as Earth. And all of these objects are Io in the upper, the very top there is about the same size as Earth's moon. So imagine if you see this up in the sky instead of our own moon at night. And Ganymede, the largest of the group, there's actually going to be a European spacecraft sent there in the next decade. And this one is larger than Mercury. These are very unique and exciting bodies. As we go out and explore them, we can see interesting terrains. Here again, we see impact craters on Callisto, the farthest out of all 4 of these satellites. But these are a little bit different. You can see how they have bright, shiny rims. And these are bright because they're made of water ice. So out at these distances from the sun, ice is actually a rock. And ice forms the lithosphere, the crust of these bodies, much like silicate rock does here on Earth. We think of basalts, we think of sandstones, those kind of things make up our crust. But here we have ice, water ice, that's the crust. And it's covered in dust, this layer of dust that's accumulated over the many centuries. If we look at, go a little bit closer into Jupiter, we will come to Europa. And Europa, a little bit smaller than Earth's moon, is a very unique and exciting place to think about visiting. A little undercurrent you'll see running through here as we go out into the outer solar system is, what is the chance for finding life, evidence of life having arisen in these places? Europa appears to be a very young surface. Where are the impact craters here? There are not very many. You can find a few, but otherwise the surface is very young. We think just a few million years old. And this is because the ice itself melts or overturns or gets broken up by the tectonic processes you can see having taken place here. So you can see the crust is split apart, and there are salts that have come up from an ocean that must not be very far below the surface. And this is a liquid water ocean, and we think that ocean is connected with a seafloor. And here's a zoom-in picture of this. And really, this is starting to look like polar sea ice, isn't it? If you look hard, you can figure out a way to reconstruct all of the plates, put them back together to what they were before. And you could even pick out a zone that you might call sort of a slushy zone. We think this is solid ice now, but at some point in the past, perhaps it was the not too distant past, it was a slushy melt. And it enabled the ocean to communicate with the surface. If we go down far enough, we might find Black Sea smokers on the bottom of this ocean. And this is actually where scientists are thinking is the place life might have gotten started on the Earth. And so now we have a similar environment. We have the energy to drive these seafloor smokers from Jupiter tugging on Europa. Sometimes Europa is a little closer to Jupiter, other times it's farther away, and so it kind of gets stretched and kneaded. And it creates a lot of internal heat. So maybe we have little volcanoes sitting on the seafloor. So this is a very exciting place for us to think about, trying to go and finding evidence of life having gotten started somewhere far away from Earth. This is 5 times as far from the sun as the Earth is. Now if we go a little bit closer into Jupiter, you start to see tiny little Io hovering like a jewel up above the cloud tops. And when the Voyager spacecraft flew past Jupiter in 1979, it was predicted that there would be a volcanic eruption scene on the surface. And it turned out, and this was based on the fact that it orbits so close to Jupiter, again, sometimes it's close, sometimes farther away, and that this tidal forces acting on Io's interior should cause melting. And sure enough, this massive volcanic eruption was seen happening out against the edge of Io. And you can see here is the center of this volcano is called Pele. And here's the center of the eruption. There's a lot of dark material coming out of the center. They're basaltic, pyroclastic materials ejected out of this volcano. And along with that is some dust and sulfur dioxide gases. And these rise up to 300 miles above the surface of Io and create a giant umbrella deposit that extends about 800 miles from the center of that eruption. So these are massive eruptions, and there are hundreds of them going on, dozens this size at any one time, and otherwise little trickles of lava coming out all across the body. And this one I'd like to point out is named after the Hawaiian goddess of volcanoes. I like that name. So as we look at Io, we can see it is completely covered in volcanoes and volcanic products. All the yellow you see is sulfur from these eruptions. The red is sulfur that's currently molten and is getting ejected out of the volcano this second. And all of the dark things you see are lava flows. So this is a paradise for volcanologists to go and look at. And actually, we think it's a good analog for the early Earth. There's so much internal heat in Io that it's generating melt, and actually we think there's maybe a magma ocean down beneath the surface, much like we had on the surface of the Earth in its early days. There's so much internal heat in Earth that there was an ocean of magma on its surface. So I got a chance to work on the Galileo spacecraft as a graduate student, and this spacecraft was making flybys of Io, and kind of in the late stages of the mission because we didn't want to fly too close to Jupiter, which is where Io was, because of the strong magnetic field and all the charged particles moving along these field lines. Those charged particles just wreak havoc on spacecraft and on instruments. And so the poor spacecraft was getting bombarded by these things, but it was worth it to try to come in a little closer to Io and see what was going on. And so every flyby, there was the chance the spacecraft would go into safe mode, which means everything sort of shuts down, it turns to Earth and says, what do I do? And we try to restart it in time to get observations, but often we just miss them entirely. And so I wonder how many people have fasted for spacecraft before. I used to do it on a regular basis. Before every flyby, I would say, okay, come on, poor little Galileo. And I remember at one point in particular, I went to Hawaii for some field work. And I got off the airplane, I called my friend, and I said, Moses, how did the flyby go? And he said, went into safe mode, we lost the whole observation. And I just laid on the bench under this beautiful palm tree and I cried. So it makes us appreciate things even more. You know, sometimes with these new spacecraft that are orbiting Mars, for example, there's a terabyte of data that comes down every day. And there are things that people haven't even looked at yet. And it's wonderful, it's fantastic. But with Galileo, just every little trickle was precious. And that's a new way for us to look at data. I think at some point we'll figure out a way to put probably a spacecraft, maybe not a person, on the surface of Io, right in the middle of a volcano, and we can look back and see Jupiter in the background like this one day. Let's go a little farther out in the solar system, 10 times as far away from the sun as the Earth, to Saturn. How many of you remember the first time you saw Saturn through a telescope? Or if you haven't yet, do that right away. Do you remember, did you look at the back of the telescope? I did. I actually looked at the back. I said, there's no way. There's a sticker on here. Isn't there? You put a sticker. Because there's no way that this can exist. And but this beautiful little planet with this tenuous, thin ring system is just hovering out there in space. And lucky for us, there is a spacecraft orbiting Saturn right now, the Cassini spacecraft, $3 billion, the last of our flagships so far. We're trying to get some others built, but people are reluctant in this financial climate. But this one is orbiting Saturn until 2017 and studying Saturn, its rings, and its collection of moons. And this is one of my favorite pictures ever taken by a spacecraft. This picture is only possible from a spacecraft. Can you imagine why? So the sun is behind Saturn here, and so we have to be on the other side of Saturn in the solar system to take this picture. And this is a little bit enhanced, as you can tell, so that we can see things like the atmosphere, we can see the rings, and especially focus on that hazy outermost E ring. I'll come back to that in just a minute. If you look really closely at this spot, where is it? I think it's up here. Tiny little dot here in the corner of the ring. If we zoom in there, then we see the Earth and the Moon. So we're looking back toward the inner solar system, seeing our tiny planet very distant from where we are here. And this is one thing that I hope is sinking in from all these talks, and especially from this last one from Professor Hellings, that distances here and times that we're working with are very great. And it's difficult for us to even put these in our mind, even for our own solar system. How far away are these objects? It takes a long time to get to these things. So as we zoom into Saturn, we start looking at Saturn and its atmosphere and its rings. I love this picture because this gives you a good indication of what the ring plane is like. That's that very thin line that is parallel to the bottom here. This is the ring plane. And all of those ring-like features you see that are dark up above are the shadows of the rings cast up onto Saturn and its atmosphere. So the sun is shining a little bit below the rings and casting the shadows up onto Saturn. The rings are only about 1 kilometer thick, half a mile thick, hundreds of thousands of kilometers across, and made of ice, big chunks of ice from particles sized up to house size. And then what we also can see in this image is this beautiful tiny moon hovering up above the rings. This is Enceladus, 500 kilometers across, about the size of Great Britain. And by all accounts, it should be cold and dead. It's very small. It should have lost all its heat early on. But when we zoomed into Enceladus, what we saw is this complex system. Again, where are the craters? It's got a young surface. It's been heavily tectonized. It's been stretched apart. It's been shoved back together. And the greatest surprise of all for Enceladus is that there are geysers of water gushing out of the South Pole. And those geysers contain things like methane and ammonia and carbon dioxide and salts. All of these things that come from a reservoir of water sitting inside of this planet. And so again, here we have something that's got an energy source, we've got liquid water, and we've got organics. Those are the ingredients for life as we understand it on Earth. And so this is this tiny, unlikely body that's suddenly a good place for us to go and look for evidence of life. And this is the source of that large diffuse E-ring that you saw around Saturn. That's water being ejected out of the bottom of Enceladus right now. Here's a kind of a companion moon. This is like Enceladus, only it didn't go through the same kind of stages. It's cold and dead. And I hope this reminds you of something that's a little bit familiar to all of us. This is the Death Star moon. This is Mimas. Okay. But the crown jewel of the Saturn system, the reason in many ways for the Cassini mission is Titan. This is the largest moon of Saturn. It's larger than Mercury. And one thing we knew from looking from telescopes at Titan is that we could tell its atmosphere is made mostly of nitrogen. Does that sound familiar? And actually it has the same pressure as Earth's at its surface. But instead of containing massive amounts of water that form clouds and rain, at Titan's location, 10 times as far from the sun as the Earth, at a cold 90 degrees above absolute zero, the liquid in the atmosphere and on the surface is methane. So there are methane clouds, methane rainfall that we think is currently happening on Titan's surface. And so there was actually a probe specifically designed to go down through Titan's atmosphere and splash down in these lakes and seas of methane. But it turns out that as we were descending, actually did see huge river channels, really well developed. These are better developed than any river channels we see on Mars. And we actually landed in, it looks like a dried up riverbed. We landed in the deserts. So what we understand from our deserts here is that, well, there will be water in these at some point, but there just isn't right now. And so here we can see these rounded cobbles of water ice. Again, we have a lithosphere of water ice on Titan. And as the spacecraft sat there and was a little bit warm, it sort of baked off a bunch of methane and vaporized that into the local atmosphere. So Titan is turning out to be a very interesting place for us and is actually turning our thoughts back again toward home, because this landscape is very much like Earth's. There are rivers and lakes and seas of methane. There are eroded mountain belts. And these lakes and seas are currently filled. They're the only other body in the solar system that has this, with these lakes and seas filled with liquid. And once again, so we have seas of liquids on Saturn, but we also have seas of sand, it turns out. We didn't expect this, but as we look in the deserts on Titan, we see vast areas of sand dunes, and these are dunes like we find in the northern Sahara and Saudi Arabia, Namibia. But the sand grains here are actually made of organics. So when methane is sitting high up in the stratosphere, it actually gets broken down by photodissociation from sunlight. It recombines into long-chain organics. We've seen ethane, propane, benzene, acetylene, and other long-chain organic molecules that then clump together, sink down to the surface, probably solidify into layers and get eroded into the cobble size, down to sand-sized particles, and blown into sand dunes. So now we have organics. We have, we believe, a liquid water ocean down beneath the icy crust. and an energy source that maybe sometimes brings this liquid up in the form of volcanoes, cryovolcanoes we call them. And so Titan is now, and plus we have oceans, just oceans sitting there of methane and organics. Titan is also a heavy hitter for places to go and look for biology. Things happen at a very slow pace here, but maybe if you lived on Titan, you'd look back at Earth and say, there couldn't be life there. Everything happens too fast. They've got a magma ocean on the surface. There's no way they could have life. So I think, again, we have to keep in mind everything is relative. We have to open our minds up to a lot of different possibilities. We'll keep going farther out. As we leave Titan, we'll leave Titan in our unmanned aerial vehicle that we want to fly over the sand dunes. We really want to make this happen at some point. And we'll go out to Uranus. Look at beautiful Uranus hovering up in the atmosphere, or up in the sky. Uranus is so beautiful because it's smooth in texture, and we didn't maybe expect this. The blue color is from methane, and Uranus was discovered actually in the late 1700s by, I'm now forgetting his name, someone help me. Herschel, thank you. And Herschel and his sister did a lot of work in cosmology in England early on. And this actually really fit really well with our understanding of what was happening at the time in terms of science. We'd sort of come out of the scientific revolution, which was just a little bit kind of cold and terse. And we were entering this age of scientific wonder when we were starting to expand our gaze out from the orbit of Saturn. At this point, we thought, well, the universe, and actually it was the universe, not the solar system, the universe ends at Saturn. And instead, he found this one other planet just beyond Saturn, twice as far from Saturn, and we could see how it was moving. And so our thoughts were starting to open up and say, well, maybe there's this other body here. Maybe the actual universe can extend even farther beyond that. So there's this gradual opening of our minds that occurred just in the late 1700s. And this is summed up well, I think, by Humphrey Davy. Nothing is so fatal to the progress of the human mind as to suppose our views of science are ultimate. There are no mysteries in nature, that our triumphs are complete, and that there are no new worlds to conquer. There are many things I was hoping to talk about, but I'll finish up by saying we're using these bodies in the outer solar system to open our minds up to the possibilities of other worlds in our galaxy, in the universe. And if you've been watching, you've noticed that all of a sudden we're finding all of these very exciting and unique bodies out in the universe, especially in our own galaxy, that are unique in their own way. You know, some of them are so close that they should be totally molten on one side and frozen solid on the other. And there are a number of these that we think happen right in the habitable zone, that has to be where there's liquid water. And just 2 days ago, the National Academy of Sciences came out with a paper that suggests there should be 9 billion planets just in our galaxy that are habitable. That doesn't mean they're inhabited, but they are habitable. That's more than there are people on Earth. So I hope that shouldn't surprise us too much. It is still surprising. It's big numbers. It's hard for us to understand this. But we should be able to look at that and say, well, we knew this because we were told that God told us those things were there. And so we should be ready to see them when they come. And that's all I have. Thank you.
So we have a few questions for you.
Okay, how about the hexagon on Saturn's North Pole? Yes, I wish I'd put a picture in there. There's this very interesting feature at Saturn's North Pole in the atmosphere that's actually hexagonal in shape. It's a very regular, beautiful shape. And what is this? It's hard for us to have these sort of regular, beautiful shapes and explain them often with natural explanations just because maybe we don't expect those things to be there in such a regular form. There were some experiments I saw done that took a pan of water and spun them at a certain frequency, and once it hit that right frequency, it actually made it a little hexagon. And so there is an explanation if you can look at this possibility that, well, it's just sort of a resonance feature within the atmosphere, but it is really beautiful. Estimates on the total number of comets in our solar system. Millions of comets. Most of them are out in the Oort cloud, which is really far distant. It's actually a fourth of a light year away, I think. The reach of our solar system is a lot more vast than we originally expected. Occasionally, those things sort of interact with each other and they come zooming into the inner solar system at really high speeds. But there are many comets, and comets are proving to be very interesting for us because, again, they have organics and other things that are interesting to us from an early solar system standpoint. What do I think of the expedition to Mars? Oh, the expedition to Mars. There are a couple of these things in place. One of them, I think, would send a couple to Mars and do it as a reality show. People always say, you know, so we're trying to send an unmanned aerial vehicle to Titan, and it's $700 million, and there's nowhere for it to go right now. But so my friend, there's no money, and I say, there's always money. There's always money. So you just need a reality show, and then you can go. There's enough money. You just have to find it. Would I like to go? One of these expeditions is a one-way trip, and I wouldn't like to go on a one-way trip. I think there are so many more exciting places to study on the Earth as well as on Mars that I'd want to come back. So I'm hoping that there would be some way to go and then come back again. By the way, in our lifetime, you can imagine being able to at least go up into space. You go up in SpaceX or the Dragon or one of these, and at least see the black of space and get some zero gravity and then come back down, and for about $200,000. So if you start saving up, you might be able to do that. That's what I'm pinning my hopes on. Are there reasons the Earth doesn't have rings? Well, originally we thought Saturn was the only planet with rings because we couldn't see any others. And then once we were able to look more carefully, we saw, oh, actually Jupiter has rings. They're mostly dust, so that's why we couldn't see them before. And Uranus and Neptune have rings as well. So our understanding of rings is increasing as we continue to look for these things out in the solar system. It appears that it's just the gas giants that have these rings, but it turns out that Rhea, which is a moon of Saturn, and it's an icy moon, it's not as big as the Earth, but Rhea has rings. So there's no real strong reason why the Earth shouldn't have rings, except for one I can think of, and that's the moon. The moon is there, and it can sort of act as a sweep and carry particles up in its own path and sweep those up. So as you can imagine, when the moon formed from a collision from something about the size of Mars colliding with the proto-Earth and then leading to the formation of our current Earth and the moon, there was a ring of debris in that system for a while. So Earth did have rings for a little while. Do I have maybe one more minute? Some of these I don't know how to answer, so I don't. Any thoughts on Fermi's paradox? And this is the paradox that if there's life out there, then why haven't we made contact with it? Is that that's correct? I'm thinking right. This paradox is, okay, now I'm talking about 9 billion habitable planets out there. Shouldn't we find life? Shouldn't life have arisen on one of those? We don't really know yet because we don't know how to predict the likelihood of life. If we were to find it in our own solar system, I think we'd be able to start saying, yeah, life is probably common if we can find it in our own solar system in addition to Earth's. Although there's some transfer of material that might occur. So it could have maybe started on Earth and been transferred. We'd have to figure out a way to determine if it just started on its own there. If it did, then we've got to start thinking of these habitable places as being likely to have life there. So then why haven't the civilizations that have attained more intelligence and more technological advancement than ours made contact with us yet? And one solution to this that I've heard is just, we're still talking about really great distances. And if there's no way for us to get around the problems with traveling at the speed of light, then they're too far away. There's no really good way for us to contact each other. So we have to get around that physics, and we don't have an answer for that yet. So I think these are still some unsolved problems. And that's all I have, I think. Thank you.